morning, class. I am going to be covering Chapter 1, Defining and Collecting Data. In this chapter, you're going to understand the types of variable used in statistics, know the different measurement scales, how to collect data. This is going to be important for your project / discussion. Know the different ways to collect a sample, and understanding the different types of survey errors. So again, this is a statistics class, so there is some probability that we're covering, but we're going to be focusing on collecting data and analyzing that data and coming to some conclusions about that data. So categorical data. This is qualitative. That means there's just information about this type of data, which has to do with like a yes or no answer, or brown eyes or blue eyes, or brown eyes or not brown eyes. It's so categorical data. Okay. The second type of data is numerical. Okay, this is quantitative. Okay, this typically deals with numbers, variables that have values. Okay, so for example, discrete is a counting process. For example, a discrete type of data would be how many televisions do you have in your home, or how many cell phones are in your family household. Okay, that's a counting process, right? We have to count it. Continuous numerical data, okay, is a measuring process. For example, we are going to measure the height of everybody in the classroom. Okay, one thing I want to point out here is this corner. Notice we're on D, and that's data. Okay, we're going to be talking about definitions of data and types of data. So one important thing is having an operational definition. If you're going to do a study, you need to make sure that you're defining your data clearly and precisely. Okay, you need to discuss that maybe in an abstract, or at some point in your study. You need to really make sure that how you're defining your data, how you measured, how you counted, all of these things are clearly and precisely described. Now, in the absence of an operational definition, we come up with a lot of miscommunications. And the reason why there's miscommunications is the whole point of taking statistics and doing analysis of it and maybe coming to some conclusions is to sort of prove a point, right? I serve on a board that distributes the HUD money that goes to low to moderate income communities. Okay, and part of each group, each nonprofit, is required to take some sort of data. Now, part of that data is their income, their socioeconomic status, their ethnic identity, and so if the operational definitions are not clear, so for example, we had one nonprofit who said they serviced over 900 clients a month. Now, this operational definition was not clear because the actual number of clients that lived within a certain zip code were less than 100. So they're servicing over 900 clients, but because they're homeless, it was like a homeless mail center, they're communicating that they service over 900. When the actual, in our neighborhood, when the actual definition of the neighborhood was less than 100 homeless people that reside, that considers themselves residents, even though they're homeless, of this particular community. So again, definitions are crucial. It actually affected their funding because it wasn't correct. So arriving at our operational definition is a key step in this DCOVA. And we're going to be discussing the D, the data part, and the collecting part in chapter 1. All right, operational definitions of terms. Okay, so first things first, a variable. Characteristic of an item or individual. For example, we are collecting data on how much milk a household buys in a month. Okay, so each individual household would be one type of variable you consider household. And the second variable, or the Y, which is dependent on the household, would be how much milk is purchased in a month. That's a simple definition. Another one would be the price of an iPhone. Okay, how varied is it? So what of this particular study, one variable would be the iPhone. The second variable in this set of data would be the price. Okay, so data, typically the set of individual values associated with a variable. Okay, so we are looking, for example, we went to what I just mentioned, the price of an iPhone, right? iPhone X. Okay, now so the data would be, maybe the store. Okay, and the other would consider that the X, and the other set of data would be the price, right, of the iPhone. Now, one of the things, again, operational definitions of terms, and we're going to get to this in collecting, but one of the things I want to mention here is, let's say you took the data of all iPhones and the prices. Okay, your outcome, or what you're going to observe, isn't going to be very accurate, because you're going to have, I'd be curious to see if they had the iPhone 3s out, right? Or whatever the lowest iPhone is to the brand new one. The new iPhone X's are about $1,200, depending on the data size. So again, identifying the definition. So you're looking for the price of a specific product. You have to make sure that when you're taking the data of each specific product, that it's the same product. Okay, so for example, the price of an iPhone X 256 gigabytes is going to cost more than the iPhone X at 64 gigabytes. Okay, and it is not a fair comparison if you're trying to figure out how much that price varies if you're comparing it to a different product. Now, statistics. This is what this class is about. Are methods, all right, that help transform the data. How can we look at a set of data, X's and Y's and a bunch of numbers under it? How do we evaluate that data into useful information for decision makers? And this is really important, honestly, in all businesses. Whether you're a for-profit business, is this product coming in the black, right? Is it making me a profit? All right. As we take this data, other types of information are maybe we're taking statistics on the housing market, right? What is the cost of a certain type of house in different zip codes? Okay, the average cost of a house of a 3-bedroom, 2-bath, maybe 1,200 to 1,500 square foot house in one zip code. How does that compare to the other zip codes in a particular city? So again, you can take a bunch of data, but can you use that data to either prove your point? So for example, for the advisory board that I sit on, is your nonprofit truly servicing a low to moderate income area? And this is where statistics is extremely important. All right, types of variables. Again, we're still here in the D area. So again, variables. So we looked at a few definitions earlier, but this table is really nice. So there's categorical information such as marital status, political party, eye color, okay? Now there's numerical information, okay? For example, the number of children or the number of defects per hour, or what is the weight of each individual in the classroom, or and you have to measure that, right? Or the voltage. So again, number of children, defects per hour are discrete examples, or they are counted items. The numerical continuous are measured characteristics. You will see in your homework, I will ask you different types of questions, and you need to label it as a categorical variable, a discrete numerical, a discrete continuous. All right, now there are levels of measurement, okay? So again, we're still talking about data, all right? A nominal scale classifies data into distinct categories which no ranking is implied, no ranking. So again, the nominal scale are, you break things into categories, where ranking is not implied. So an example is, for example, do you have a Facebook profile? Your question to a group would be, do you have a Facebook profile? And their answer would be yes or no. Okay. What types of investment do you own, right? Growth, value, or other. Again, you need to provide the answers, right, that they're going to choose. They're not open-ended one. What cellular provider do you have, right? AT&T, Sprint, Verizon, other, or none. Okay, these are types of categories. Again, AT&T, Sprint, right? There's no ranking in it. It's just I have AT&T. Okay. An ordinal scale, this is one above a nominal scale. So nominal would be the lowest form of measurement. There's just categories. Are you married? Yes or no. Do you have children? Yes or no. Did you go to college? Yes or no. Okay. These are types of categories. Now, an ordinal scale are also categories, but there is a ranking. For example, class designation is a very common one. Are you a freshman, sophomore, junior, or senior, right? First, second, third, or fourth year high school student, or college student even. Product satisfaction. Obviously, in an ordinal scale, there is a ranking involved. Are you very satisfied, or are you are you very unsatisfied, right? Which unsatisfied would be the bottom, and very satisfied being the very, very top. Faculty rank, right? Where do you fall in the list where professor has the most seniority? Associate professor means you've probably just been newly hired on. An assistant professor means maybe you teach this particular class with some regularity, but maybe you don't have tenure. An instructor, you teach whatever class they hand you. There's no tenure, there's no benefits, etc. You're the lowest ranking instructor among the four: professor, associate professor, assistant professor, and instructor. The Standard & Poor bond ratings. Again, these are stocks and bonds investments, and you are rated. Are you a triple A at the very top, or are you a D at the very bottom? And what you guys are all very familiar with, your grades, right? Obviously, you can be ranked in A, B, C, D, or F, right? But you want an A because that is the top ranking. So an ordinal scale. So the first one was nominal scale, the lowest of measurements. Ordinal scale, which is also a category but requires ranking. The next one is an interval scale. And you will be asked different scenarios and what type of measurement are these. An interval scale is an ordered scale in which the difference between measurements is a meaningful quantity, but the measurements do not have a true 0 point. Okay, and we'll talk about examples of that in a minute. A ratio scale is an ordered scale in which the difference between the measurements is a meaningful quantity and the measurements have a true 0 point. So interval means it starts from 0, right? Like there is a bottom, basically, that's what a 0 point means. So for an interval scale, there's not a true bottom. For a ratio scale, there is a true 0 point, or it starts from this particular point. So okay, let's talk about some examples of interval and ratio scales. Okay, so again, interval scales, there's no true bottom, meaning there can be negative values and positive values. Okay, so for example, in the temperature, minus 54 degrees is just as valid as a positive 54 degrees. It's really cold, but it is a valid temperature. The standardized exam scores such as ACT or SAT, while yes, you can get a 0, they have typically average scores, right? And you can also have a negative score as well, depending on how you score, how many problems you get wrong. Now, height, weight, and age, there's a true 0, right? You cannot have a negative height. You cannot weigh negative pounds. You cannot be negative number of years. You're just not born. It's also in salary. You can't have a negative salary. They have to pay you something, right? There's a true 0. You cannot have no negative values. No negative values. All right, so establishing a business objective focus data collection. So again, now we are on data collection. Okay, so examples of business objectives. Let's take a look at this first one here. Marketing research analyst needs to assess the effectiveness of a new television advertisement. Okay, so as a company, we want to see how effective this advertisement is. There's all kinds of marketing research that even happens on Facebook. How effective is your Facebook advertisement? You can actually go on and there's analytics about that. If second one, if pharmaceutical manufacturer needs to determine whether a new drug is more effective than those currently in use, they would do a statistical study for that. An operation manager wants to monitor manufacturing processes to find out whether the quality of a product being manufactured actually conforms to company standards. This one's not on here, but maybe a hospital is going to collect data on the quality of care patients are getting from nurses, or the quality of care patients are getting from the doctors. And this last one here is an auditor wants to review the financial transactions of a company in order to determine whether the company is in compliance with the general accounting principles. So again, how are we collecting this data? First thing you need is an objective. What are you looking for? You have to have a mission or an objective or a hypothesis before you can even begin collecting data. It's important when we're collecting data that we do it correctly. Again, starting with the right objective, making sure we're defining what our variables are and what we're looking for. This is really needed because, our data can be flawed by biases, ambiguities, or just other types of errors. Results from flawed data. So typically you're using data to prove a point, right? You're using it to prove your hypothesis. And so if you say all of this data is true and correct, and you don't take into consideration any biases, ambiguities in your definitions, or you don't look for possible errors in your data and you're saying, yes, this is all true and correct, it proves my point, etc. And, you know, people can't trust your results. And so notice, it seems like, oh, a very common thing, but even the most sophisticated statistical methods are not very useful when the data is flawed. Now, one example of this data is all of the polls said during the election prior to a very famous one, prior to Trump's election as United States president, that there was no chance, there was no way that he was even going to make a dent. Now, he did lose the popular vote, but he he won every swing state in the United States, and putting him way over the top. By about 8 o'clock that night, I think I was actually teaching a class, and my students mentioned, why aren't we canceling class? It's the election, and so part of the class we were watching some of the results, and by 8 o'clock Trump had won, had for the most part won the electoral votes, and by 9 o'clock there was no way that Hillary was going to make up for the electoral votes. He had won every single swing state and all of these sort of extra votes, if you want to call them that, in the election. Now, sources of data. Now, there's primary sources. So, for example, as a data collector, you are the one actually going out and taking a political survey, or you're collecting data from an experiment, and you're measuring every person in your class, right? Or you're the one actually taking you're observing this particular data. Now, secondary sources, which you're going to be utilizing quite a bit in this class, is maybe you're getting data from the census, right? How many renters are there in the zip code 92113? You would look that up online. Or you can examine data from print journals or data published on the internet, and you will be doing quite a bit of this. It's actually part of your first project, is looking up secondary sources of data. Sources of data fall into 5 different categories. The first is data distributed by an organization or an individual, outcomes in an experiment, responses from a survey, conducting an observational study, or data collected by ongoing business activities. Okay. So data distributed by an organization would be the national census, right? Outcomes of a designed experiment, that would be like flipping a coin, right? Responses from a survey, a hospital taking responses, are you very satisfied, and all the way down to, are you very unsatisfied? Results of an observational study. I guess an example of this would be, how many SUVs are parked in the parking lot of a mall, maybe during a given time frame, compared to smart cars. Okay. Data collected by ongoing business is how many 4K TVs are sold in the month of July. Examples of data distributed by organizations. Again, I'll try to go through this quickly. Financial data on a company provided by investment services, industry or market data from market research firms or trade associations, and stock prices, weather condition, and sports statistics from daily newspapers. Data from an experiment is consumer testing different versions of a product, which product should be pursued further, material testing to determine which suppliers materials should be used in a product, and market testing on an alternative product promotions to determine which promotion to use more broadly. I actually saw this and not necessarily in a product promotion, but it was a commercial they were testing. And if the commercial did well in this local zip code, it would go into a regional area, and then the commercial was going to go into a national area. And that was kind of my first experience with that while I was in college. Survey data, right? Asking people which type of laundry detergent has the best stain removing abilities. Political polls of registered voters during political campaigns. Who are you going to vote for, right? President Trump or Hillary Clinton. People being surveyed to determine their satisfaction of a recent product or service. I'm sure if you go to a dentist's office, a doctor's office, or even a restaurant, maybe they'll email you and ask you, please rate the quality of service, and they'll ask you to take a little survey monkey. Examples of data collected from observational studies. Market researchers utilizing focus groups. Okay, so focus groups is one type of way to elicit unstructured responses to open-ended questions. The second type is maybe measuring the time it takes for customers to be served in a fast food establishment. Actually, I think it's either a midterm or maybe a final question. It's asking, we're going to do some analysis on the data that they give on how long it takes for the bank to service each customer. Okay, and last but not least, maybe measuring the volume of traffic through an intersection. So, measuring the traffic throughout the day at a specific intersection to determine whether some sort of safety is required or expansion is required. That's actually been done quite a bit on our freeways, and that's how they determine whether we need to add a new freeway or expand the new freeway. That's how in San Diego, that's how the 805-5 merge happened. There was too much traffic on the 5. We needed alternative routes, and then they had these studies and the observations to prove that this particular freeway, the 805 the 5 is backed up, requiring the use of another freeway. Examples of data collected from ongoing business activities. For example, the bank studies years of financial transactions. As a business, you can study the years of your profit and loss. Okay. In this particular case, maybe you can identify patterns of fraud. Economists utilize data on searches done via Google to help forecast future economic conditions. That's how they sort of determine whether we're a bear or a bull market, or this was sort of part of the housing bust that happened in 2008. People kept saying, buy, the housing prices are going to go up, and then it kind of blew up. And everything, lost its value, along with several companies went out of business. Marketing companies use tracking data to evaluate the effectiveness of a website. Actually, I have several friends in this business. It's a job. You track the effectiveness of advertising done online or the usefulness of online websites, and you actually pay consultants to collect that data for you and then turn it into something useful. To determine whether maybe they need to put more money into the website, or they need to maybe take the website down and just start from scratch. So data collection from either a population or a sample. A population here consists of all of the items or individuals about which you want to draw a conclusion. A population is the large group. Now, typically, we can't ask every single person what they thought of Sharp Hospital. Have you had an interaction with Sharp Hospital? But you can take a sample, right? Maybe the hospital will sample 1 out of every 10 patients, okay? Or they'll just ask all of their patients, and then hopefully they get at least 1 out of 10 to respond to the survey. This is the small group. All right, so for example, all of the items or individuals which you want to draw conclusions about are the population. This is a nice way to visualize it. And the sample as well, maybe we'll just ask a few people in this group, and hopefully it's a good representation. It is an unbiased representation of what we're trying to represent. So collecting data via sampling is used when selecting a sample. We take samples because it's less time consuming. I actually can't imagine trying to ask, well, that's why the consensus takes so long, and they require so many hundreds of volunteers in every city. It takes quite a bit of time. I think it actually takes them a whole year to do this census data. So taking a sample is less time consuming than selecting every single item in the population. It's less costly, right? The more time is money, right? You have to pay people, you have to either administrate the volunteers or organize the volunteers, and you have to file all of this information somewhere. It costs more money the longer it takes to do a survey, and it's less cumbersome, right? It's more practical than entire. I can't imagine asking every single person their income, right? But maybe if I ask one out of every 100 households in a population of 70,000 households, it's still quite a bit of time, but you're still asking a lot less than 70,000 households. Now, things to consider. Is your data structured or unstructured? How did they take the data? How did you take your data? Were you only asking specific people? Maybe only your friends and family? Then you're going to have some sort of bias, right? How did you collect your data? What kind of structure or lack of structure did you have? How is the data formatted? How are you putting your data together? How are you storing it? Did you just take out, so maybe you did some analysis and you had some outliers. Did you just take those outliers out? You actually can't do that. You have to represent all of the data that you took. And how is your data encoded? So again, we're still talking about data collecting, right? Structured data follows an organizing principle and unstructured data does not. Now that seems simple, right? But let's take a look at these examples. A stock ticker provides structured data. A stock ticker reportedly reports a company name, the number of shares last traded, the bid price, and the percent change in the stock price. This happens all the time. Due to the inherent structure, data from the tables and the forms are very structured. Now, emails from 5 people concerning stock trades is an example of unstructured data. In these emails, you cannot count on the information being shared in a specific order or format. We're just sort of taking the questions as they go, and everybody's going to ask a different type of question. The book deal will almost always deal almost exclusively with structured data. So in this course, we're going to be focusing on structured data. Almost all, so some of the methods, we're not going to be looking at chapter 17, but for many of the questions you might want to answer, the starting point will be tabular data. So we're going to be taking the X's and Y's, or the several sets of X's and Y's, and we're going to be organizing them. To deal with unstructured data, you will probably need to seek out help with more advanced methods and techniques, but we're going to be focusing mostly on structured data. All right, so we are at 34 minutes. I'm going to do my best to get through this quickly, but we're on slide 26 and there are 42 slides, so we are a little bit more than halfway through. So bear with us, maybe push pause and take a break. Make sure you're taking notes. You will have questions to answer after watching this video. So data can be formatted or encoded in more than one way. Some electronic formats are readily usable than others. Different encodings can impact the precision of the numerical variables and can also impact the data compatibility. As you identify and choose sources of data, you need to consider or deal with these issues. How are they encoded? How precise is the data? We often find irregularities in data. This is common, right? Sometimes they're typographical. Maybe we just entered the information wrong. How many times have you entered phone numbers in wrong? I do a little bit of bookkeeping, and that's the importance of reconciling, because at the end of the month, maybe you added something twice, maybe you added something incorrectly. Either way, typographical errors or data entry errors. Values are impossible or undefined. Maybe some of these values we can't reach. Maybe there's missing values, or maybe there's outliers. Okay, so irregularities. So I mentioned earlier, maybe you have some outliers, and I was asking you about how your data was collected, and maybe you just took out those outliers. You can't do that. You have to figure out what those outliers are. Maybe take your data again and see if those outliers are still there. When found, irregularities have to be, not should be, they need to be reviewed and addressed. Okay? We are going to be using Excel and not Minitab to address these irregularities and to examine them. After collection, it is often helpful to recode some variables. So recoding a variable can either supplement or replace the original variable. I just read this first point here. Recoding a categorical variable often involves redefining categories. Okay, so how are you defining things? Right? Do you need to redefine them? Do you need to recode them? Recoding a quantitative variable involves changing the variable into a categorical variable. And then when recoding, you need to be sure that the new categories are mutually exclusive, that categories do not overlap and are collectively exhaustive. Categories cover all possible values. A sampling process begins with a sampling frame. What does that mean? A sampling frame is a listing of items that make up the population, right? iPhone X, 256 gigabyte, and then the price. This is our population. Or everybody in classroom A. Frames are data sources such as population lists, directories, or even maps. Inaccurate or biased results can result if a frame excludes certain portions of the population. Now, using different frames to generate data can lead to dissimilar conclusion. So again, how are you collecting this data? What type of data are you collecting? How are you defining it? Figure out a frame. Where does everything need to stay within? Because if you're getting a bunch of data from with different frames, you can't rightly compare them. You can't even really do an analysis on them because you're not comparing the same thing. So samples, let's take a look at samples. There's this big word, samples. Now, you can take a look at non-probability samples, right? These are based on judgment. For example, quality of care. And these are based on convenience. Everybody in classroom 120. Probability samples can be simple and random, 1 out of every 10 people that pass through the line. Can be structured, can be systematic, or can be a cluster. First 100 people, right? So let's take a look at non-probability samplings. Let's take a look at these definitions. Convenience samplings are selected based on the fact that they are easy, inexpensive, and convenient. It's exactly what it is. It's a convenience sampling. They are without regard to their probability. We're not concerned if this happens regularly, right? We're not concerned about the probability of how this happens. Now, judgment is getting the opinions of pre-selected experts, okay, on a subject matter. So now let's take a look at these other ones: simple, random, systematic, stratified, and cluster. Probability samples are chosen on the base of known probabilities. So, with every chance or item from the frame has an equal chance of being selected. Selections may be with replacement Selected individuals is returned to the frame for possible reselection or without replacement. So selected individual isn't returned to the frame. For example, there are 8 white balls and 4 green balls. Now you can do the selection with, we're going to take a ball out and then not replace it. That's without replacement. Or we're going to take a ball out and then put it back in and keep taking the samples that way. Our samples obtained from a random number of computer random number generators. So let's take a look at this example. Selecting a simple random sample using a random number table. So sampling frame for population with 850 items. So here we have names, item names and item numbers, right? And we're going from 1 to 850. And now here are a portion of sample random numbers. And again, a bunch of different numbers. But we are going to organize them. Decide on a sample N, right? How many people are you going to ask? So for example, we're going to ask every 4th person, or the 4th person in every row, okay? Decide on the sample size, 4th person in every row. Divide on the number of individuals. We're going to ask 100 people and put them in groups of 10, and we're going to ask the 4th person in every group of 10. Randomly select one individual from the first group, that would be this person, and now select every 10th person thereafter, okay? So that was a probability. A stratified sample. Divide the population into 2 or more groups, called strata, right? According to some common characteristic. Then randomly select from each subgroup with sample size proportions. So notice they're asking 3 people from every group, right? There's a yellow group, a green group, a blue group, and a gray group. Let's say this population is divided into 4 groups based on the color shirts they have. So everybody on this one has yellow shirts in the first row. The second row, everyone is wearing green shirts. The third row, everyone is wearing blue shirts. And the last row, everyone is wearing gray shirts. And they're just randomly selecting 3 people from every row. All right, the population is divided into several clusters. This is a cluster sample. What does that mean? A simple random sample of clusters is selected. All items in the selected clusters can be used, or items can be chosen from a cluster using another probability sampling technique. A common application of a cluster sampling involves exit polls, right? As everybody leaves, we're going to ask you a few questions, where certain election districts are selected and sampled. Probability sample, comparing sample methods. Simple, random sample, and systematic samples are very simple to use, right? It's just randomly selecting people or having some sort of systematic sample. But they might not be a good representation of the population's underlying characteristics. For example, we're going to randomly select people coming into the store at 9 a.m. You are missing all of the sort of working population, maybe. A stratified sample ensures representation of individuals across the entire population. We're breaking them up into groups, and then we're randomly selecting people in groups. There's a little bit more representation. Cluster samples are the most cost effective, but they are less efficient because they need a larger sample to acquire the same level of precision. We're going to discuss this idea of normal distribution. What do we need to have a certain level of precision when we're analyzing our results? Evaluating survey worthiness. So here are some questions that you can ask, and here are some errors that tend to happen. What is the purpose of the survey? Okay, is the survey based on a probability sample? And what are the appropriate frames? Is there coverage error? Now, what happens if you don't get the responses? Maybe you're going from for every 10th person. Maybe you have a handful of 10th people that don't want to respond or do not respond. Did the group follow up? Measurement error. Measurement error happens all the time. As physicists, when I worked in a lab, we had to remeasure the same samples several times, and then we would take an average of those samples, and we made sure that our results were repeatable. Good questions elicit good responses. Maybe the questions were poor, and a sampling error that always exists. Typically, if you'll read a survey, they'll give you some level of error in the results. So these are good questions to ask. These are good questions to consider, especially as we approach our projects and attempt different problems. There are types of survey errors. There's coverage error. There's not enough coverage, or there's bias in our selection. For example, we only ask one type of group these questions. These errors exist if some groups are excluded from the frame and have no chance of being selected. Non-response error or bias, people who do not respond may be different from those who do respond. Okay, sampling error, variation from the sample to sample will always exist. For example, what I was telling you was the measuring the same samples. And so obviously we didn't get the exact same results, but we got it within a measurement of error. We tried to stay within 5 to 10%. Measurement error, this is typically due to weakness in the question design, or the respondents didn't answer correctly, or was in a hurry, or just checked all of the A, and really wasn't responding. So mostly due to weakness in the question. The question's too broad, it's not specific enough, the objective is not clear, the definitions aren't clear, and so it's hard to frame the question. All right, so again, here are the different things we discussed again. A coverage error, we excluded a group from the frame. Non-response, there is no follow-up. Sampling error, or you can follow up on the non-responses. Sampling error, take a different sample and see if that you get to about the same average. So again, taking the measurement again. Measurement error, you got to maybe look at your question again. Maybe your question isn't specific enough, or it's too broad. All right, so we talked about types of variables used in statistics. This is going to be important. I ask you a lot of those questions on the homework and the midterm. I ask you a lot of questions on the measurement scales as well. How to collect data and different ways to collect data are going to be important for your project. The discussion for this week is the beginning of a project you're going to be working on this quarter, and you're going to need to be able to look at these sets of data and determine if there are any survey errors. Maybe you need to find another set of data, and I will be helping you with that portion of the exam. So that is it for chapter 1. Please go to the classwork section and answer questions based on this video.